Hello students, today we'll start with the next part of our topic dynamics in mechanics. Two particles connected with a light inextensible string. So here I will put a question, and as I discuss the question, I will make the concepts clear with you. So this is a question here. Which is exam type question. So let us mark the important things given in this question first. So here two particles P and Q, of masses 6 kg and 4 kg respectively are connected by a light inextensible string. This is very important here. Particle P is pulled by a horizontal force of magnitude 10 Newton along a rough horizontal plane away from Q. Particle P experiences a frictional force of magnitude 3 Newton and particle Q experiences a frictional force of magnitude 2 Newton. Find the acceleration of the particle and tension in the string and explain how the modeling assumption that the string is light and inextensible is used. So, first let us draw the diagram here. This is the horizontal plane here. On this horizontal plane, there are two particles kept. So out of this, one particle, say P, is of mass 6 kg. So suppose this is P, whose mass is 6 kg. Other particle is Q, whose mass is 4 kg. And these two particles are connected by a string which is modeled as light and inextensible. So this is the light inextensible string connecting the two particles. Okay. Now particle P is applied a force of 10 Newton and it is pushed away from Q. So this is a force of 10 Newton here. And the particles are on the rough plane. So there is frictional force, and obviously the frictional force will be directed away from the motion. It will always oppose the motion. So the frictional force is in the opposite direction. So P is experiencing a friction of magnitude 3 Newton and Q is experiencing a friction of magnitude 2 Newton. Now, let us come to part C first. Here, The string is modeled as a light and inextensible string. Light. Now, what do you mean by string is light? Its own weight is negligible. And since its weight is neglected, that means a uniform tension is developed in the string. And since the particles are pulling each other, there will be a tension T in the string that will be directed from Q to P, and by Newton's third law, equal and opposite tension will be there, which is directed from P to Q. Okay, so when I say that string is light, that means its own weight is neglected, and hence, because its weight is not acting on itself, the tension that is in the string is uniform. That is the first modeling assumption you have made here. And second, the string is inextensible. Now, since the string is inextensible, that means its length is not changing when it is pulled. Okay, and hence it will by itself not either pull or push the particles, and hence both the particles both the particles accelerate at same rate. That means the acceleration of both these particles will be the same because the string is inextensible. And this is how the modeling that the string is light and inextensible we are going to use in the problem. So now here, first is we have to find the acceleration. So part A, you are finding the acceleration. So for finding the acceleration, we will consider the full system. That means we will consider both the particles together with the string. Now let us find out the resultant force that is acting on the complete system. Now 10 Newton is acting in the direction of motion, and minus 3 the force of friction on P in the opposite direction, and 2 again in the opposite direction, that is the friction acting on Q. Now since I considered the complete system, see that the tensions in the string are going to get cancelled because the tension is uniform and they are equal and opposite. A tension from Q to P and other from P to Q. Both are equal, they are opposite, and hence they are going to get cancelled. And this is how the modeling assumption that the string is light is going to help me here. So the resultant force is of 5 Newton. And now I will use the Newton's second law. F is equal to m into a. F is 5. Now the total mass of this system will be 6 plus 4, 10, because the string is light. Its mass we have neglected. So which means the acceleration of this system will be 5 upon 10, that is 0.5 meter per second square. So both these particles will accelerate at the same rate of 0.5 meter per second square. Now in the second part, we have to find out the tension in the string, tension that is developed in the string when the particle is pulled. Now to consider to find out the tension, we'll consider only one particle, either P or Q. And it is better to consider the particle on which minimum forces are acting. So obviously that is particle Q. So here we will consider particle Q. Now the resultant force on particle Q is T in the forward direction minus 2 in the backward direction. And that is equal to, by Newton's second law, mass of the particle 4. And since the string is inextensible, now both the particles are accelerating at the same rate of 0.5. And this is how the modeling assumption that the string is inextensible is helping me. So T minus 2 is equal to 4 into 0.5, that is 2. And hence T is equal to 2 plus 2, that is 4 Newton. And part C, as we have already discussed, string is light. String is light means its own mass is neglected, and hence the tension in the string, is uniform. So the tension T will be developed from P towards Q, and equal and opposite tension T from Q to P. Okay, so when I'm considering the complete system, both the tensions will get cancelled, and string is inextensible. Now string is inextensible means its length is not changing when it is getting pulled, and hence the acceleration of both the particles is the same. Both the particles will accelerate at the same rate when one of the particle is pulled. Okay, so this is how the modeling assumption, the string is light and inextensible, is used in this problem. Now I'm giving you one question to solve by yourself. So this is a very similar question that you can try yourself for the homework. Okay. Any doubts, please make them clear in the next class. I'll see you in the next class with the next topic, which these assumptions, modeling assumptions are okay with you. So see you in the next class, students. Bye. Enjoy the day ahead.